Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is string RP or PR. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that given a string S, in one operation you can remove the substring PR from the string S and get amount X, or you can remove the substring RP and get amount Y. Okay, and your task is to find the maximum amount you can get if you perform 0 or more such operations optimally. Okay, and one note is given here about what is substring, and after removing RP the order of remaining letters should remain the same. Okay, one example is given here. Let me explain the example. Okay, so example says that you're given x equals to 5 and y equals to 4, and you have a string which is a b p p p r r r. Okay, from this string what I can do is I can remove this pr. Okay, since I'm allowed to remove pr, so I can remove this pr and get amount, okay, x here. Okay, so after that the remaining string will be a b p p and r r. Okay, from this string again I can remove this pr, so I will get amount x again, and after that the remaining string will be a b p and r, and you can see we can remove one more pr from here and we will get amount x again, and then the string will be ab. Now there is no possibility that I can remove one more pr from or any rp. Okay, so the final string which we have got is AB, and this is the amount that we have got. Let's check what is the total amount. The total amount is x plus x plus x. It is 3 into x. Okay, and what is the value of 3x? Okay, so it's like confusing, so let me write 3x simply. Okay, so 3x is the amount, and if I write 3x then I will get 3 into the value of x is 5 and 15 is going to be my output. So you can see that 15 is the output here. Now I hope you guys got the clear understanding of the problem statement. Now let me talk about the solution. Okay, so after looking at the problem, the first thing that comes to my mind is try out all the ways. Which ways I'm talking about? I'm talking about the ways of removing either RP or PR from the string. Okay, fine. So let me take an example. The example I'm going to take is a string which is rp rrp. Okay, and I'm going to take value of x equals to 5 and y equals to 3. Now in this string what I can do is, okay, in this string I can either remove this rp, okay, or I can remove this pr, or I can remove this rp. There are three possibilities that I have, so let's try out all the possibilities. When I remove this rp, then the string I will get is rrp. Okay, and when I remove this pr, then the string I will get is, okay, pr will be removed and I will get rrp again. Fine, and here when I remove this rp, then I will get rpr as my string, so rpr I'm writing here. Okay, fine. Now in this string again I have an option that I can remove this rp, so let's do it. When I remove this rp, then I will get r. Similarly here as well, I remove this rp and I will get r. There are two possibilities again. Let's check all both. The first is remove rp and get amount y. Okay, so if I remove this rp I will get r, and here if I remove this pr and I will get amount x, and the remaining string will be r. Now these are the possibility that I have. So now let's check the amount of all the paths that I have explored. So the first one is remove this pr. When I remove the okay, the first one is remove this rp. When I remove this rp, then I get y as my amount. After that, when I remove this rp again, then again I get y as my amount, so it is basically y is 3 and 3, so the total is 6 for this path. Fine. Now for this I'm removing pr, so means I'm having amount as x, which is equal to 5. So let me write 5 here. and when I remove this rp, then I get amount as 3. Okay, so the total amount here is 8. Fine. Now for this path I am removing rp from here, so I will get amount y, which is equal to 3. And for this here I am removing y rp, which is giving me y amount, which is 3. Okay, now I hope you guys remember that for rp I will get y amount, and for pr I will get x amount. Fine. Now the total amount for this path is 6. Fine. For this I am removing PR from here. So PR gives me amount X, which is equal to 5. Okay, so the total amount here is 8. Now out of all these possibilities, you can see that 8 is the maximum amount that we can get. So 8 is going to be my output. Okay, by looking at this, I hope you guys are clear with the approach, like what we are going to do. Basically we are going to try out all the paths recursively. Okay, so let me write even the pseudo code for this. What I'll do is I'm going to write the pseudo code. So if I have a string like rp rrp, so for this I'm going to iterate for each character. I will have a function which is having string str. Fine. And the function will also have like x equal to 5 and y equals to 3, but let's consider it global for now. Okay, fine. Now if my string length is 0, then I will return 0. Okay, now one thing that I can do is I can iterate over all the characters. So for all characters in str. Okay, so actually it is for loop. So for all characters in str, if current character current character is equal to r, this is the code that I am showing you for the PR. Like I will search for PR. Okay, no, actually this is wrong, but let me write this. If current is equal to r and next to current, which is my next character, is equal to p, then what I'll do is my maximum. Okay, so I will have a max here. Let me change the color. So I will have a max variable here, which I am going to maximize. Okay, so I will have a max here, which is initially equal to 0. And what I will do is here I will write my max equal to max of the current max that I have, and I have my, okay, here I have r and p. So if I remove this rp, then I will get y amount, and after removing I will have a string. So the string after removing, let's take it is s. So I will remove this. I will write this. Okay, fine. One more thing that I can do is I can write here else if. Let me take the same color again. So else if my current is equal to p, like current is equal to p and next equal to r. So this is basically the case for PR. And for PR, when I remove, I get the amount as x. So let me write it. I'm going to write the same line here, like max equal to max of max that I already have, and x plus function of s. Okay, so this is what I'm going to write. Now I think you guys may confuse with like what exactly is this s. So s is the string after removing string after removing PR or RP. Okay, so this is what I'm going to do. After that I will have a max when this loop completes, and then I will simply like return max. This is what I'm going to do. So now I'm going to show you the implementation. With the implementation you will get more clear understanding. So let me show you the code. You can see the code here. On the left side I have written the Java code, and on the right side I have written the C++ code. Okay, so you can see that the code is like very much similar to the pseudo code that I have explained. If the string length is 0, then return 0. After that I will have a long variable which is basically keeping track of the max. After that, here if my string like I equals to 0, I smaller than string length, okay, -1 because I am checking the next current character as well, so it can go out of bound. That's why I have taken -1 here. Fine. This is something very important. This says that the string after removing will be this. How? Let me give you a brief explanation. So if I have a string like a b c r p m n o, so if I'm at this position and I have to remove this rp, so basically I will take a string from 0 to I minus 1, 0 to I minus 1, and then I will take the string from I plus 2 to length, so I plus 2 to length, and this is the same thing that I'm doing with the code. Like you can see that what I'm doing here. Okay, after that, since this is rp, so for rp I have to add y, and the similar case is here, but here I have pr, and for pr I am going to add, like you can see that I am adding here x. After that, when this loop completes, then I will have my max, and I will simply return max. You can see that when I am calling this recursion utility function, then it is something which is recursive implementation. So this is how I am going to solve the problem, and this is the C++ code on the right side. And now let's talk about the time complexity of this approach. Okay, so talking about the time complexity, this is really tricky kind of thing to calculate the time complexity for this. Like I have a function which is recursive function, and inside this I am having a loop. So it is a for loop, and for all characters I am again calling the function. So but I'm calling the function when I have a particular condition, like if I have rp or pr. So the worst case can be I have rp. For this kind of string, it will call again and again like the same function. So it is going to be very close to n factorial. I'm not saying exactly n factorial, but it will be close to n factorial for worst case. Now this is really lot of complexity, and now we are going to optimize it. So let's talk about the optimal approach now. Okay, here I am going to take a string as an example. So let's take string equals to rpr. So okay, this is the optimal approach. So let me write optimal as my heading. Now I am going to take this rpr as a string. Okay, from this string you have two options. You can either remove this rp or remove this pr. If you remove this rp, then you will get r, and if you remove pr, then again you will get r. So pr removing here and rp removing here. Fine. Interesting thing is, when you have removed this rp, then there is no option that you can remove pr, because p was something which was overlapping. It is like overlapping of rp and pr. So when they overlap, then they form rpr. Fine. So you can either remove rp or remove pr, but which one to remove? Which one to choose? This is the question. For this, my value of x and y will come to play their role. Like x is something which is equal to 5 and y is 3. You can see that x is having greater value. So when I remove this pr, then I will get 5, and when I remove this rp, then I will get 3. So here you can see that this is something which helps us to build the intuition for the greedy approach. So we can go greedy here. Why? Because we have to maximize the cost, right? Maximize the amount, I mean. So I will choose here pr because pr is giving me more amount. So let me write the observation here. Like overlapping is the condition which is very important to handle. So if x is greater than y, then I will do something else. If y is greater than x, I will do something else. Very important. Now what to do? This is important. Let me tell you that if you have rpr and you have x as greater value, so what you will do is you will try to remove pr first, so that this overlapping condition is handled. I mean, if you remove pr again and again, then it may you will get maximum amount of x, because at the end, okay, and let me write a general formula, which is if I have performed if I have removed pr 3 times, and if I have removed rp 4 times, then what is the total amount? Let me write this here. So for the string, like string equal to rp, okay, any string. If I have like a is the amount of number of removals of like pr, okay, and b is the number of removals of rp, like this many time I have removed rp from this string. So what is the total amount? The total amount in this case is going to be a into x. Okay, let me write simply that the total amount is ax plus by. Do you agree? Like if I have removed pr from pr a times, then x will be multiplied with that a times, then I will get the total cost for pr removals, and for this I will get total cost for rp removals. So this is the total cost that I'm going to get. Now for this case, like if x is greater than y, I will first remove rp. So first remove, okay, I will first remove pr as many as possible, pr as many as possible. So I'm not going to write this, I'm just saying that as many as possible pr there, then I will remove them. After that, second, remove rp. Quite simple, right? After that, here the case will be reversed. Here I will first remove rp, and second remove pr, right? Why? Because in this case I have to maximize the value of a, because x is greater. Then in order to get the maximum cost, I will maximize the value of a, and in order to maximize the value of a, I will first remove pr. Why? Because it may be possible that in the string like rpr, if I remove rp, then I will not be able to remove pr. So first I will I will be being clever. I will try to remove PR first. Then I will see that okay, if there are RP possible, then I will remove RP. Fine. So that's why I am writing this here. Now this is the intuition which is going to used in order to solve this problem. Let's talk about the like implementation and approach now. So in the approach, what I'm going to do is, first of all, I'm going to check like if x is greater than y, then I will call a function. Okay, so I'm going to have an array which is int elements. What is this array about? This array is all about calculating the value of a and b. A and b I have already explained you here. If you see like what is a and what is b. So I'm going to store the value of a and b in this array elements. Fine. So when I have x greater than y, then I will have get elements. Okay, I will fill the values in these elements, and I will pass characters like p and r, and I will have then string. Okay, what that tells us? It says that like elements array will be equal to this function. This says that first remove pr, then remove rp. Fine. And if y is greater than x, then my elements array will be equal to get of r first, then p, then s. This says that first remove rp as many as possible, after that remove pr. Fine. And now you are going to ask a question from me that how to remove rp or pr from a string. Like if I have a string, let's take a string. If I have a string something like a b p p p r r r, let's take the same string as example. So this is my string, and you are going to ask that hey, how to remove like rp or pr from this string, let me tell you. This is where stack comes to play its role. Like stack is going to be used here. What I will do is, let me give you like kind of dry run of the approach, then you will understand yourself. Okay, so if I have string like this, then what I will do is I will keep adding the characters in this stack. Like you can see that I will traverse these characters. Like I have a, then a, add a to stack. After that I have b, then add b to stack. After that I have p, then add p to stack. After that I have this p, then stack p, then add p to stack. After that I have this p, then add p. After that I have r. This is breakpoint. Why? when I have r as the like string. Okay, so this is for pr when I am wishing to remove pr from this string. So you can see that I have p as the stack top element and I have r as the string current element. So if stack top is equal to, okay, even let's take these characters now. I'm going to take c1 and c2 as my character, which is storing this character. Okay, so if my since you can see that I have like rp here, so what I can do is I can count. I have r here. Then what I will do is, if I have stack top as my, okay, if my stack top element is like c1 and current element is c2, like stack top is r and current is p, so this is case for rp. So I will remove rp, like I will pop this element from this stack. So now I have removed this part and I will not add this. So you can see that I am removing this and I am not adding this, means I am removing this total part. Okay, fine. Now after that what I'll do is, so let's write like stack pop and just, okay, then I will increase the count for pr. Like I have removed this. Okay, this is the case for rp, so I have removed rp, and when I removed rp then I will increase the count for rp plus plus. Fine. Else I will simply add the thing. Like if I, okay, you can see that what I was doing, like if there is no such case then I was simply adding. So else I can simply add to stack. Fine, this is the kind of approach that is going to be used. After that I come here, and here as well you can see that this is p, this is r, so again we are going to perform an operation, so this again will be removed. After that I come here and again I have pr, so this r and this p again going to be removed, and after that I will have ab in the stack. This is how we are going to achieve this. So now what I'm going to do is I'm going to move you to the okay, I'm going to show you the code for this approach. Okay, so here's the Java code and here I have the C++ code. This is the get function, but I will start from the starting point of this function, which is solve function. First of all, I am creating an array element, which I have already explained you. After that, if my x is greater than y, then I am going to have function like this. This means that remove pr first, then remove like rp. Okay, and this means that remove rp first, then remove pr, and at last you can see that element 0 is same as a, which is the number of operation for removal of pr, and number of elements for like removal of rp is element 1. Fine. You can see that C++ code is very similar to this. Now I will go to the get function that I have. Okay, let's see this function. This function says that I have count 1 and count 2. Okay, so I don't know what this count 1 and count 2 is storing. So first of all I will come to this. Okay, and if my I is equal to 1, okay, so I am starting from the 1, and then because I am starting from 1 because I have already added the 0th character in the stack, and I have used temp as my 0th character. Fine. Now I am doing the same thing that I have told you. Like if my current character is c2 and like top character is c1, then I am going to pop and I am going to increase my count, and else I am simply going to add to stack. Now till now I don't know what this count 1 is about. Okay, so this is the same thing that I'm doing here, and when this loop completes, then what happens is in this stack, like, okay, when this loop completes, then stack s1, now s1 is going to have, when the loop completes, then s1 is going to have string after removals. Okay, fine. Either it can be removal of rp or pr, doesn't matter, but after the removal of the first that I want, like either pr or rp, I will have in the stack. This s1 is stack. Fine. Now I am going to add the first value of stack in the in second stack s2, and I am going to do the same. Just the difference is now as my string, this s2 is acting, this s1 is acting. Now this s1 is acting as a string and s2 is acting as this stack. Fine, you can see that the same thing I am doing here, and after and even I am increasing the count 2 for this, the second operation that I want to perform. At last, this is very important line. This line says that if PR, if my current character C1 is P, then my count 1 is storing the count for removal of PR, because you can see that if my first character is P, then I want PR to be removed first. So that's why I am passing count 1 first, because count 1 is for PR. And here else, in else condition, I will have this RP, and for this RP you can see that I am passing count 2 first, because count 2 is storing the removals of RP, and then I have count 1. So this is all about this problem. I hope you guys like the solution and you are able to understand what I have done here. So this is all about this problem. Thank you.